Hey, OChemsters, this is Mrs. Vanderlei bringing you section 10.10, preparation of esters. In other words, how do you make esters? Oh, and notice, this is still here. If you can make water, you will make water, all right? So when a carboxylic acid and an alcohol are heated in the presence of an acid catalyst, what happens? All right, so here is my carboxylic acid, and here's my alcohol. And what I just say, if you can make water, you will make water, all right? I was very careful. Which H am I using? I'm using the H of the carboxylic acid because it's an acid. Acids are proton donors, are H plus donors. And then the OH of the alcohol acts like a base. Kind of like the same way that the OH negative ion hydroxide is a very, very strong base, all right? Alcohol is not hydroxide, and alcohol is an OH group attached to a carbon. Hydroxide is an OH negative attached to a positive cation. Just keep that in mind. So what do I make? Now notice I have these color coordinated. All right, same as before, same as last time. The blue is from the carboxylic acid. The red is from the alcohol. So when I make my water, one of the H's is from the carboxylic acid, the other OH is from the alcohol. All right, so here's my ester, here's my water. So again, how do you name this? You name it from this is an important idea, by the way. You may want to jot something down. The carbon that's off of the single bonded O here came from the alcohol, and then of course this comes from the carboxylic acid. So write the reaction of the preparation of propyl butanoate. I'm going to make propyl butanoate. That's my product. All right, so my propyl is here and my butanoate is here. Of course, I'm also going to make some water. So what are the two things I need? Well, what's in the blue? The blue comes from the carboxylic acid. So I have 4 carbons here, so that I have butanoic acid. My 3 carbons here, my propyl, the first word here comes from my alcohol, so that's propanol. So I need a butanoic acid and I need propanol to make propyl butanoate. All right. So why don't you take a little bit of time out and you do octyl ethanoate and see how you do. All right, make it. So that's your product. So what 2 reactants do you need to make octyl ethanoate? Well, this was kind of a long one. Hopefully you wrote small. Let's just put it that way. So here is my octyl ethanoate. Octyl is again the first part of the word. So I had to have 8 carbons attached to the single bonded O. And then my ethanoate is from my carboxylic acid. And don't forget, you're going to make some water. All right, so what is my carboxylic acid? I needed a 2-carbon carboxylic acid. So that's your ethanoic acid. And then I needed an 8-carbon alcohol, otherwise known as octanol. All right, so there you have it. Well, thankfully, letter B was not quite as long to write out. I want my ethyl butanoate. So here's my ethyl. Here's my butanoate, all right? So what did I need to make that? Oh, by the way, make some water too. So what is my carboxylic acid? It's in the blue. So I need butanoic acid. And what is my alcohol? I end up with a 2-carbon alcohol. So here it is. Actually, I could probably, there we go. It looks a little better, doesn't it? Okay, so what about pentyl propanoate? All right, well, what does pentyl propanoate even look like? Looks like this. I have 5 carbons here, and here's my propanoate. And don't forget, you're going to make some wawa. And so what were my 2 things you're going to need? You're going to need a propanoic acid. Okay, so the propanoate is your propanoic acid, and then you need your pentanol right there. Okay, so that was a pretty quick one, wasn't it? Don't wait to be great. And I believe that ends our discussion in chapter 10. So we'll see you next time. Bye-bye.